Can you able to see the board properly? Can you able to hear me now? Kindly reply who all are present. So today we are doing a revision on electromagnetic wave, numericals as well as question answers. Today and tomorrow both day I am taking only revision on this chapter. Okay. So yes, Mayuka is there, Rujul is there, Malvika is there, and who all are there? Can chalo. Okay. So write down the question. What is the amplitude? Write down the question. What is the amplitude? What is the amplitude of the electric field? What is the amplitude of the electric field part of the wave? What is the amplitude of the electric field part of the wave? So only what is the amplitude of electric field part of the wave. So here no other information is given. So we know that amplitude C is equal to E naught by B naught, and they are asking for electric field. E naught is equal to what? C into B naught. That's it. This is the answer. Okay. So C is nothing but here velocity of a light in a vacuum, and this relationship gives the amplitude of electromagnetic waves in the electric field. Okay, so write down this. If you know here the magnetic field, I don't know here magnetic field, but I know the C. If you want, you can put the value 3 into 10 raised to 8 into B naught, and this is nothing but what your electric field. Okay, copy this. Copy this fast. Okay, write down the next question. Write down the next question. In a plane, electromagnetic wave, in a plane, electromagnetic wave, the electric field oscillates sinusoidally. In a plane, electromagnetic wave, the electric field oscillates, sinusoidally with a frequency of 2 into 10 raised to 16 hertz, and amplitude is nothing but electric field is given whose amplitude is 48 volt per meter. Amplitude is 48 volt per meter. First bit, what is the wavelength of the EMF wave? What is the wavelength of the EMF wave? Second they are asking, calculate the amplitude of the oscillating magnetic field. Calculate the amplitude of the oscillating magnetic field. Okay. So here it is very clearly given that there is an electromagnetic wave and whose electric field which varies sinusoidally, whose frequency is given f is equal to 2 into 10 raised to 16, and E naught means electric field amplitude is given 48 volt per meter. So they are asking here, first is wavelength, correct? Wavelength they are asking. So we know that lambda is equal to C by F. Okay, C is nothing but speed of a light in a vacuum, that is 3 into 10 raised to 8, and frequency is 2 into 10 raised to 16. So 3 by 2 is nothing but 1.5, and 8 minus 16 is nothing but 10 raised to minus 8 meter. This is what the lambda. That's it. This is the answer of first bit. Now second, what they are asking? They are asking the magnetic field. Just now we did this formula. C is equal to E naught by B naught. B naught oscillating magnetic field they are asking. So here we will get B naught is equal to E naught by C. So E naught is given 48 and C is nothing but 3 into 10 raised to 8, that is 16 into 10 raised to minus 8 Tesla is the magnetic field. So this question they asked here for a 3 marks. I hope you all are getting. Those who have a doubt, they can ask or keep a message. Paxton, where are you yesterday? Paxton, कहाँ था तू? Okay, copy this and practice these questions at home also. Okay, and in this same question they are asking energy density. Okay, energy density of electromagnetic wave for electrical field. What is the formula for energy density? We did know. U is equal to half epsilon naught into E square. So half epsilon naught is 8.84 into 10 raised to minus 12 into E square, that is 48 into 48. 48 into 48. Simplify this, check this 2, that means 4.42 into 48 into 48 into 10 raised to minus 12. Check this, what is the answer? Check what is the answer here you are getting. Is it 10.10? Is it 10183.68 into 10 raised to minus 12? 1, 2, 3, 4. 4 means minus 8. Okay. So 1.018 into 10 raised to minus 8 joule is the answer. Okay, third bit. Actually, I forgot to tell that. This is the third bit. Okay, finished. Everyone copied. Everyone can. I hope everyone is copied. Okay, you all are getting the questions. Is someone having any doubts? Okay, write down the next question. Find the wavelength of the electromagnetic waves. Find the wavelength of electromagnetic waves of frequency. Find the wavelength of electromagnetic waves of frequency 6 into 10 raised to 2. 6 into 10 raised to 2 hertz. 6 into 10 raised to 2 hertz in a free space, given sorry, not given, give two applications, give two applications of the type of wave, give the applications of the type of wave. This kind of questions are very very important. Okay, why important? Wavelength so we can able to calculate, because we know that wavelength formula is nothing but c by f. Frequency is given and c, to by default we know that we will get the value for lambda. But whatever the wavelength we are getting, that wavelength I told you to prepare the table. So check this wavelength is fit into which spectrum, and then you have to mention that this is related to which spectrum, and then you have to write the applications of that. Okay, so in exam they will not ask any direct question, what are the ranges for infrared, what are the ranges for UV rays. They will not ask. We have to calculate the wavelength, then find out it is lying in which band, and then give the applications. Okay, so you must know that wavelength values. I told you to learn that, okay, with powers. So now write down the given things. So here frequency f, how much is given? Frequency 6. Yes, 6 into 10 raised to 2 hertz. Okay, lambda they are asking. Lambda is equal to c by f. Okay, so 3 into 10 raised to 8 divided by 6 into 10 raised to 2. So 3 ones are 3, 3 twos are 6. So 0.5 into 10 raised to 6 meter. Okay, this is nothing but what? Your lambda. So 0.5 into 10 raised to 6 means how much? देखो कितना आता है 0.5, can go for that side. Then 5 into 10 raised to minus, going for that side, 5 no, minus 1. 5 meter is a lambda. I think check, maybe this is fall in the infrared region, infrared application. This is nothing but infrared wave, and infrared waves we know that in remote controls we are using them to treat the muscular strain. Okay, what are the application to treat muscular strain, as well as for remote control, and in TV remote controls. Okay, so this is what the question. Okay, finished. Now next question, write down. Okay, write down the next question. Write the following radiations in a descending order. Write the following radiations. Write the following radiations in a descending order. In a descending order of frequencies. Descending orders of frequencies. Red light, comma X-rays, comma microwaves, radio waves. I'll repeat. Write the following radiations in a descending order of frequencies: red light, X-rays, microwave and radio waves. They are asking descending order of frequencies, very important. Okay, so I gave one mnemonics, how to recall these mnemonics, that also I told you. Okay, and what is increases and what is decreases, I gave that things. So we know that radio, Mirchi, I love you, Xerox gun. Okay, radio waves, microwaves, infrared. Then this is nothing but what, UV rays, then X-rays, and then gamma rays we have. Okay, so here they are asking descending orders. Okay, descending order of the frequencies. Okay, तो फ्रीक्वेंसी डिसेंडिंग ऑर्डर में लिखना है. तो क्या होता है, कहाँ डिसेंडिंग ऑर्डर फ्रीक्वेंसी है. सो इफ आई एम गोइंग फ्रॉम रेडियो वेव टू गामा रेज, व्हाट अबाउट द वेवलेंथ. वेवलेंथ इज व्हाट, डिक्रीजिंग, नो, and frequency increases. Correct. I gave the same things to you. So here how can you write? Here we can write it as we have here X-ray, means either X-ray frequency in descending order, no. So X-ray, then after that which is given here, red light. Okay, red light. Then after that we have a microwave, and then radio waves. Okay, decreasing order है, so this is what the arrows. Okay, X-rays are greater than the red light, and red lights are greater than the microwave, and microwaves are greater than the radio waves. That means radio waves are what, here shorter. So writing only descending order in a proper way, you will get 2 marks. So for that you should know that mnemonics, where in which direction lambda increases and frequency decreases, that you have to remember. Okay, finished. Everyone copied. Write down. Next question. Write down the next question. Write the applications of infrared radiations. Write the applications of infrared radiations. Write the applications of infrared radiation. Just I told, no, but if you want some other applications also, I can give that also, because variety of application you have to learn, because anything they can ask in exam. So basically infrared not only used in remote and other applications. So suppose the wall contains any secret information, that is also read by this my infrared. And suppose wherever there is a hazy situations are there, where we are not able to take a photographs, there this infrared helps us to take a image. Okay, so first in hazy conditions, not conditions or situations, IR used to help to take photographs, and even to read the secret messages from the walls. For writing correct exact application you are getting out of out marks in this chapter. Okay. I hope you all are getting. If you have any doubt, queries, you can message me. Okay, finished, copied. Write down the next one. Next question. Which constitute radiation? Which constitute radiations of the electromagnetic spectrum is used question mark. First one, to photograph internal parts of the human body, to photograph internal parts of the human body. Second, for an aircraft navigation, for an aircraft navigation. I'll repeat this question. Which constitute radiation of the electromagnetic spectrum is used? First, to photograph internal parts of the human body. Second, for an aircraft navigation. So here actually they give the application. So here we have to identify which waves are used or which spectrums are used in this application. First, what they are giving here, first they are saying the photograph है ना of the human body. तो definitely human body का internal parts का photograph ले रहे हैं, तो first is nothing but what, X-ray. And what about the second application they are asking, which one, which question is yeah, aircraft के लिए we are using microwaves. That's it, खलास. Okay, copy this. हो गया. So next one, write down electric field in the plane electromagnetic wave. Electric field in a plane electromagnetic wave is given by, here they are saying the electric field in the plane electromagnetic wave is given by, write down, Ez is equal to 60 sine of 10 raised to 3x divided by 2 plus 10 raised to 11 into 3t by 2 volt per meter. Volt per meter. The electric field in the plane electromagnetic wave is given by Ez is equal to 60 sine 10 raised to 3x by 2 plus 10 raised to 11 3t by 2 volt per meter. First we write down, write an expression for the magnetic field. Write an expression for the magnetic field. Write an expression for the magnetic field. Second, the magnitude of a wavelength, and frequency of the wave. Magnitude of a wavelength and frequency of the wave. And frequency of the wave. Okay. First question is that write an expression for the magnetic field. Okay. So in electric field we know that. Okay. So normally we have the electric field like this. We are writing E is equal to E naught sine of kx plus omega t. Okay, this is what the standard expression for electric field. And for magnetic field, B is equal to, we have B naught sine of kx plus omega t. So this part, similarly here it is get repeated. Whatever this portion is there inside this bracket, the same bracket will come here. Okay, sine functions are also same. But the problem is that here if we B naught is, we don't have B naught, we have to calculate. So how can you calculate B naught? Any values are given here. Okay, if you check this and if you compare this, then you will get here E naught as a 60 volt per meter. This is a maximum amplitude of the electric field. So once you know this, we have a formula, no? C is equal to E naught by B naught. Then from this we can calculate B naught, E naught by C. So E naught I have 60 and this is 3 into 10 raised to 8. So 3 2 means 20 into 10 raised to 8 Tesla is the B naught. Getting? So once I will get this B naught, substitute over here, no? So B naught B is equal to, I am getting B is equal to 20 into 10 raised to 8 sine of the same thing will come 10 raised to 3 x by 2 plus 10 raised to 11 3t by 2 Tesla. This is what the expression for the first bit. Understood? So practice this question. Same questions you can practice. Practice these questions. Very simple. Use brain and calculate at least whatever the questions I am giving here. If you are practicing questions also enough. Okay. Once you will get this, then here second bit what they are asking, magnitude of a wavelength and frequency. Okay. From this we have to calculate wavelength and frequency. I hope everyone is copied up to here. If you get here, then we can go for wavelength. So it is clearly given omega t and this is also omega t. If we compare here, see 10 raised to 11, 3t by 2 is equal to this omega t. So this t get cancelled. Okay. So here 10 raised to 11 into 3 by 2 is equal to omega, and omega is nothing but 2 pi into f. Okay, so this is 10 raised to 11 into 3 by 2. So now frequency I want, I will transpose all the things over here. 10 raised to 11 into 3 by 2 into 1 upon 2. This 2 is get reciprocal and this is pi I will substitute as a 22 by 7. So it is get reciprocal. Okay, that is 7 by 22. Now simplify this, it will come a huge value. 88 into 10 raised to 11 hertz. This is what the frequency. Okay, and if we want to calculate lambda, C by F, C is nothing but 3 into 10 raised to 8 divided by 21 by 88 into 10 raised to 11. So this is 7. So 88 will go up. 88 by 7 into 10 raised to 11 minus 8 is nothing but 3. That is minus 3 lambda meter. So you can simplify. You will get the answer 7 ones are 7, 1 तुम्ही 14, 2.5 something into 10 raised to minus 3 meter is the lambda. Okay, so like this we have to find out. You can solve this as a puzzles, then definitely you will get the answers. Okay, copy this. Everyone copied. Copied. Chalo, next one. A radio can tune. A radio can tune into any station. A radio can tune into any station. Into any station. In the 7.5 megahertz. In the 7.5 megahertz to 12 megahertz to 12 megahertz to 12 megahertz band to 12 megahertz band. Full stop. What is the corresponding wavelength? What is the corresponding wavelength band? What is the corresponding wavelength band? A radio can, I will repeat this, a radio can tune in any station in the 7.5 megahertz to 12 megahertz band. What is the corresponding wavelength band? Okay, corresponding wavelength band they are asking, and here two different frequencies are given. Okay, two different frequencies are given. For that two different frequencies we are getting two different wavelength. Okay, so for that frequency band we will get the means wavelength band also. So first frequency F1 means that radio station can tune in between, actually that is tuning in between 7.5 megahertz. Okay, and another range is given, that is nothing but 12 megahertz. Okay, so mega means 10 raised to 6. Okay, so this I will write it as 7.5 into 10 raised to 6 hertz. Okay, and this will come 12 into 10 raised to 6 hertz. So these are the two different frequencies are there. So in between this frequency the station can tune. Okay, means below 7.5 it will not tune, or above 12 megahertz it will not tune. That radio station can tune only the frequency range between 7.5 to 12 megahertz. So here we want to calculate the wavelength. So we can directly write lambda is equal to C upon F1. So C is nothing but 3 into 10 raised to 8 and F is 7.5 into 10 raised to 6. So this, remove the decimal, this will come 30 by 75 into 10 raised to 4. Okay. This is 2 by 3 into 10 raised to 4 meter. So 2 by 3 is nothing but what? 0. 0. How much we will get? 0.444. Check, do the calculation. टू बाई थ्री का आता है 0.666 0.666 into into 10 raised to 4 meter. And similarly you can calculate lambda too and type the answer in the chat box. So I will check that. You can solve this second part and I will check the answer. Someone can type the answer if you are solving or solved. हो गया सबका? How much is the answer? Someone got the answer? किसी को 25 मीटर? Okay. Exact 25 you got? Hello? Hello? मम्मी है वो खाली दाल होके वाला क्या चालू है यार? हाँ हाँ. ओके हो गया सबका? कितना मिला है? 25 मीटर. ओके. I made here 2 by 3 is 15 by 15 5s are 75, no? 2 by 5 something, correct? So I made mistake here. 2 by 5 here, 2 by 5 will come. I think this will come 4 4 4. That is nothing but, can we write here 40 meter? Okay, and this is what you got, 3 into 10 raised to 8. Rujul, your answer is correct. Here this is 12, no, into 10 raised to 6, 1 by 4. That is nothing but 25 into 10 raised to 4 meter. Means 25 meter. Okay. Yes, this is the answer. Calculation जिसको नहीं आ रहा है, they can ask and practice it. Okay, write down the next question based on MCQ. Which one of the following is not? Which one of the following is not electromagnetic in nature? Which one of the following is not electromagnetic in nature? First option X-rays. First option X-rays. Second gamma rays. third cathode rays, and last infrared rays. I'll repeat, which one of the following is not electromagnetic in nature? First X-ray, B gamma rays, C cathode rays, and last infrared rays. Okay. So which one is not the electromagnetic wave? So cathode ray we never heard no in the spectrum. We know gamma rays, we know X-rays, we know ultraviolet rays, we know the visible light, we know the infrared, microwave, radio waves. These waves we know, but we never learned the cathode rays. Cathode rays, they can emit the electrons when you are keeping in a proper position, means in the electron gun is there inside our TV or in computer screens and all. So there is what generation of a cathode rays. So cathode rays are not comes under the spectrum, electromagnetic spectrum. So here correct answer is cathode rays. Getting? Tick mark this cathode rays. One minute. Just 2 minutes. Okay, write down next MCQ. If E and B, if E and B represent the electric field, E and B represent the electric and magnetic field. If E and B represent electric and magnetic field vectors of the electromagnetic wave, of the electromagnetic wave, of the electromagnetic wave, of the electromagnetic wave, the direction of propagation, the direction of propagation, the direction of propagation the direction of propagation the direction of propagation of electromagnetic wave, the direction of propagation of wave along options are given. First option E, second option B, third option B cross E, and last option E cross B. Okay, so which one is the correct answer? So those who were there at the first session, they can able to answer this. And I told you there is electromagnetic waves, and electromagnetic waves are perpendicular to each other. So here E bar cross B bar is the correct answer. Okay, and their direction of propagation is also perpendicular to the both fields. Copy this. Next, write down. Next question. An electromagnetic wave can be produced when charge is first moving with a constant velocity, second moving in a circular orbit, C falling in an electric field, and D last option B and C. Option B and C. Option B and C. Okay, so find out the answer and tell me. I am waiting for your answer. I told you how electromagnetic waves are produced. Okay. How electromagnetic waves moving with a constant velocity, whenever they are accelerating, then only when the charge is accelerating or moving with a constant velocity, then only it can able to produce the electromagnetic wave. Okay, so that is option A. Oh, wait, not option A. They are asking what? Mm, just wait. Another, they are what? Falling in the circular orbit. Sorry, moving in a circular orbit. Okay, it is moving, no? It is moving means continuously its velocity is changing, and see falling into the electric field. Okay, then option D is the option, correct option, B and C. Because constant velocity means zero acceleration, no, there is no acceleration. But if it is moving in the circular orbit, okay, if suppose we have this circular orbit, then that is what continuously moving and it changing the direction. To change the direction it requires some time. So during that its velocity is changing. Okay, continuously velocity is changing. So there is what? Acceleration generated. And I told you whenever there is a charge is oscillating or accelerating, then that can produce what? The magnetic field. Even that charges are falling into the electric field. In that case also they can able to produce the electromagnetic wave. So option D is the correct option. That is, both are responsible. Option B and option C both are responsible. That's what you can choose the option D. Last option. Okay. Okay, write down. Um, yeah, write down electromagnetic waves with a wavelength. Electromagnetic waves with a wavelength. First bit, write down electromagnetic waves with wavelength. First bit, lambda 1 is used. Lambda 1 is used in satellite communication. Lambda 1 is used in a satellite communication. Second, lambda 2 is used in lambda 2 used. Lambda 2 is a wavelength they gave. Lambda 2 is used to kill germs in the water. Used to kill germs in the water purifiers. Lambda 2 is used to kill germs in the water purifiers. Third, lambda 3 is used to detect. Lambda 3 is used to detect leakage of the oil in underground pipelines. Lambda 3 is used to detect the leakage of the oil in underground pipelines. Fourth, lambda 4 is used to improve. Lambda 4 is used to improve visibility in runways. In runways during fog and mist condition. During fog and mist conditions. Okay, then write down next. First bit again we have sub questions. Identify and name the part. Identify and name the part of electromagnetic spectrum. Identify and name the part of the electromagnetic spectrum to which these radiations belong. To which these radiations belong. Second, arrange these wavelengths in the ascending order with their magnitude and last write one of the application of each. Write one of the applications of each. Okay, so it's clearly given. Okay, everything is given very clearly. Those who know the application, they can easily identify. Okay, so here lambda 1 is actually used for what? Lambda 1 is for satellite communication. For satellite communication we are using what? The microwaves. No? We are using microwaves. And in lambda 2 is used to kill the water, means to kill the germs in the water purifier we are using. So that are nothing but UV rays. Then lambda 3 is nothing but what? To find out the leakage in the leakage of the oil in the underground water, underground pipelines. Okay, so for that we are using, again here we are using two x-rays. Okay, x-rays are going deeply, so we can use here x-rays. And even to improve the visibility on the runways. In runways what we are using, does anyone know? Does anyone know visibility purpose what we are using? Everyone knows that on the airport side, okay, runways contains that red and green color lights are there. Yes, can you able to tell? Yes, can anyone? Can you know anything? Infrared is there? Okay, there is what? Infrareds are used, no red colors are there, and their uh, length is also more. Infrared rays. Okay, so these are the rays we have. So we identified these three. First part. Now second, identify the name of the each part of the spectrum. Yes, we identify this. Then they are saying arrange the wavelengths in the ascending order. Wavelengths are in ascending order means here wavelength is decreasing. No, ascending order means here X-rays means lambda 3 is a greater, then lambda 2, then we have lambda 4 and lambda 1 which is having lowest wavelength, and I will write it like this. So this is what my second bit. Okay, and write down the each application. No, so infrareds we can use in a photography, X-ray to find out the fractured bone. Okay, and UV rays to preserve the food also, and microwaves we are using for finding out the nuclear structures and all. Okay, and even microwaves are used in the telecommunication purpose, broadcasting and all. Okay, so copy this kind of questions, sub questions they are asking, which are very important. Again we have a tuition in the evening. What time I told you? Muscat time at 5 o'clock. Okay. Everyone can copy this. I hope everyone is copying. And those who are not there, they can check the video. I am not responsible. Okay. I am taking the revision questions. Whatever possible things are there, I am doing for you. Okay, I hope everyone is copied. So I will end this session. We can meet in the evening.